Good, there we go. So today I'll be talking, in this presentation I'll be talking about the entangled economics of killer whale depredation in Western Alaska. And I'm changing hats here a little bit. This work was part of my PhD project, and we brought in two very brilliant economists that helped us think about this issue in a new way, because this really boils down to economics in a lot of cases in operations. So this was a really fascinating kind of step away from looking at some of the more biological data. We took an interdisciplinary approach when we attacked this issue. Okay, so we've been highlighting a lot of the important implications associated with depredation, and killer whale depredation in particular. So, as we've well established, catch per unit effort, or catch rates, decline, and with that you are of course looking at increased operating costs for the fleet. We've also established there's increased uncertainty in stock assessments, and there may be some negative biological implications with increased risk of entanglements, altered foraging strategies for the whales. So this is, in a lot of ways, this is mostly lose-lose, right? And for this project, we had two primary objectives. And so first off, we just were looking at depredation frequency and the CPUE reductions for the commercial fleet in Western Alaska. And I've already presented some of that, so I'm going to glaze right over that and talk about this second objective. And here we wanted to estimate some of those increased operating costs, so things like additional fuel and additional crew food that are associated with depredation. And also, to estimate something that kind of gets ignored, these opportunity costs, which we looked at in foregone wages. So if you're not fishing, if you're sitting on the grounds just waiting for the whales to leave, or if you're traveling because you couldn't fish a certain grounds, you're looking at foregone wages. And so that's what I say when I say opportunity costs. That's what we use to estimate that. There's different approaches to do this. This is just one way to do this. So basically, in the simplest form with this presentation and with this analysis, we were trying to assess the costs of two potential responses to depredation. And this is, it's like very practical. First off, you could choose to fish through the whales. And so we had to use two different data sets. And for this, we worked with that commercial fishery data that I've talked about. We used a generalized additive model, estimated those CPUE reductions, and then we used a new approach, and we used a linear model to estimate additional fuel consumption, and I'll explain that in another slide or two. The other response that is very common when especially killer whales show up is you avoid depredation. And so this could be by whether you drop your gear back down or you move to a different site, however you want to deal with that. And so for this, we worked with fishermen collected depredation data. So this was data collected on the fishing grounds. And we used this really detailed information to get at some of those direct effort inputs and those opportunity costs. And, in the simplest form, what this boils down to is fishing choices and associated costs, right? You could opt to fish through the whales. You're looking at operation costs increasing. So things like you're going to need to use more fuel and more bait because you're fishing longer. Or you can choose to drop your gear back down and do an extended soak. But in particular, you're looking at opportunity costs. You're just sitting there. You're not working. You're not making money. Or move to a different site. And breaking that out, you have increased operation costs and those opportunity costs of travel time when you're not fishing. So a traditional approach for this is to look at the actual or predicted lost catch and then assign a dollar value per kilo or per pound. And this is a very valuable and important exercise. But what we wanted to do with this analysis is sort of bring in a new approach that I think is very relevant, especially for the sablefish fishery in Alaska, but I also think to the Patagonian toothfish fisheries. And this is where the economic theory kind of comes in. With high value longline fisheries, high value per pound that is, fishermen will fish longer to catch their quota. So it's not necessarily just an issue of lost catch. It's really the economic cost is these reductions in CPUE, or catch rates. And so if you're looking at these reduced CPUEs, the effort inputs must increase proportionally to catch the same amount of quota. And so that's what we're trying to estimate with part of this analysis. And so it's on that principle that the effort inputs must increase proportionally to catch the same amount of quota that we based our subsequent analyses. So this figure just shows the observed commercial fishery where we were tracking sets. The red squares, this is graded out data because it's confidential, represent areas where depredation occurred. And broken out by management area, you can see Bering Sea, 21% of sets were impacted. Much lower percentage of sets were impacted in the Aleutians and Western Gulf of Alaska. CPUE reductions are significant though. And despite the variable number of sets impacted, we see a strong signal. So, 50 to 70%, give or take, CPUE reductions when whales are present. So that's just, so you have this information, this exists, but what we didn't know was how to estimate additional fuel consumption associated. So if you fish through, if your set was labeled as depredated, how much additional fuel did you have to use to catch that same amount of fish? And so we set out to do this using the observer data first. And this is actually really tricky, and I think you guys might have a way to do this much easier because you have fewer vessels, so you can track this kind of information quite easily. But we didn't have standard fuel consumption data for this data set. So instead, we used detailed trip information from 60 longline fishing trips in Western Alaska. And based on a method established in a totally separate topic, but by Tiedemeyers in 2001, we regressed gallons of fuel against horsepower times days at sea. And you can use this method to establish an average fuel consumption rate. And we did this for vessels less than 100 feet and greater than 100 feet. And so you can take this information, and then we were able to extrapolate these average fuel consumption rates to the observed fleet, for which we did have vessel size and horsepower information. So this is our first step. And we can take this to estimate the cost of fishing through the whale. So you have this fuel consumption rate that I have circled here, times the days at sea, times average vessel horsepower, and that gives you a sense of the average gallons of fuel consumed per set. And you can take this estimated gallons per set, take it one step farther, times that CPUE reduction that I showed, and this gives you a sense of the additional fuel needed. You have your additional fuel needed and assign a dollar value to that based on fuel prices, and this is the average cost of fishing through the whale per set. So at the most basic level, this is how we sort of looked at additional fuel needed to fish through the whales. It's not cheap, and this definitely has an impact on any kind of business model. So that was one way to look at this, but what's the other response that you could do? You don't and in most cases, folks aren't fishing through the whales, right? So we then wanted to look at the cost of depredation avoidance, and this part in particular, this kind of work hadn't been done, looking at the sort of detailed economics of these responses. So we did a detailed study with 6 vessels in 2011 and 2012, and in Western Alaska we had 846 sets that were monitored for this. So we recorded just the number of sets affected by depredation, but also these avoidance measures, which is where you were limited with the observer data. Distance traveled, hours waited, et cetera. It's really detailed information that we asked these guys to fill out. And so you can see here just some of the basic, but then down here we have, if you continued hauling with the whales present, we asked some basic questions. If you dropped the gear back down, how long did you wait? If you traveled, how far did you go? And so we also asked for basic vessel information. And we had this for these sets in 2011 and 2012. And by taking all this information and putting it together, we get average cost per set. So in a lot of cases, there was some traveling involved. So additional fuel needed, additional crew food, and these opportunity costs, which are mostly associated with those wait times. We get a total of $564 per set, just if whales show up and if you avoid them. So that's not good either. And so you can compare this to this other value that I showed with regards to fishing through the whales and just using more fuel to deal with it. So maybe you look at this, well, it's cheaper to fish through them, that's great, but unfortunately, this doesn't take into account, this term in particular, the additional bait that you'd be using, the crew food, the opportunity costs. So some of those additional costs we didn't get at with this way of looking at it. But most importantly, if you fish multiple sets per day through the whales, if you're feeding them, they're likely to stay with you. And last but certainly not least, the whales are reinforced for staying with your boat, and they're likely spreading the behavior if you're just consistently feeding them. So based on that, our conclusion is it's likely not beneficial to keep fishing. So what did we find? Dropping the gear back down is moderately effective, right? You can wait the whales out to a certain extent. And this does reduce the risk of entanglement or bycatch for the whales potentially. But this is costly. Lost time, increased operation costs. You're risking, of course, fish quality degradation, sand fleas, and gear loss, potentially in high current areas, etc. And of course, whales can depredate stationary gear. If it may not be set that deep, it's possible. So that's something to think about. Moving to outrun the whales is moderately effective. Again, reduce the risk of entanglement or bycatch, and they're not interacting with the gear, potentially. Doesn't always work. As Paul's mentioned, you have to travel a significant difference to move beyond the whale's range. Again, it's very costly with the increased fuel usage, lost time, and operation costs. And depending on your vessel size and the weather, this may not be a feasible response in some cases. So just in conclusion, again, CPUE reductions are high, and the percentage of sets affected are really variable by killer whales in Western Alaska. Depredation avoidance measures were quite costly, over $560 per set, just averaging. Fishing through the whales per set was also expensive, though, with just additional fuel considered. But based on some of the long-term risks of feeding the whales consistently, we think depredation should be the preferred avoidance long-term solution until we get a better solution, a silver bullet that really solves this. And at the time, we were really excited about this analysis. It just represents a new way of looking at some of the costs for the fleet. And depredation has absolutely changed the nature of fisheries in Western Alaska. It's affected the season timing. It's influenced a transition to pot gear in all management areas now, including the Gulf of Alaska this last year. And the fleet is forced to use really costly avoidance measures to operate. Killer whale distribution and social learning could absolutely facilitate the spread of the depredation behavior. They've been in the area for a long time, and they've been interacting with the gear in the Bering Sea since the 60s. But that's not to say that this problem isn't getting worse. And just the standard plug that cooperative research and proactive mitigation is essential. And that's it. Oh, okay.
The initial agenda had a presentation from Eduardo. This was removed, so we have time for questions. Oh, you actually have... Yeah, go ahead, ask questions, yeah.
We just don't have a predation model that allows us to estimate the predation in our fisheries. So there is no way we can say how much we are losing because of the quota, the fishing quota that has been fixed due to this study that doesn't include the depredation. And we don't have any way to estimate our cost due to the depredation. I've just seen your very, very interesting your analysis. I think that for us it could be a lot of ceteris paribus. You have fixed too many variables to get to that result. Mm-hmm. So for us, and what I wanted to say is that we don't, Globalpesca at least, we don't have any way to estimate costs or benefits because we don't know how much they are eating. Yeah. That's it. So a little sad my intervention, but that's the truth.
No, I think that's the first step. You need a two-pronged approach to if you're going to even get at the economics. And I will, with the economic part of this study, you have to take some leaps. So it has some, it's informative for sure, but you're taking leaps. But in your case, yeah, it's this, whatever it is that, whatever steps Chile in particular needs to take to try to standardize record keeping so that you can compare the catch rates with and without, even if there's different gear types or different vessels. That'll be the first step in understanding the problem.
Yeah, I know. We have tons of data, but we don't know the model, so we cannot estimate. That's what I'm asking to this meeting, in fact. Okay.
Thank you very much. The extra cost per set is $564. What is the average overall cost? In other words, what is the extra cost as a percentage of what the normal cost would be?
That's a great question. And, I don't know, maybe Jeff could answer that in more detail. I'm not quite sure. So, because we were just looking, in that case, I should have this information. That's a great way where I've summed it all for standard sets versus, and I don't have that. I'm sorry. We're just add that amount. I was just trying to see if and when whales show up, what are the additional. I didn't look at sort of the average on a standard set.
I think Megan kind of captured a lot of, there's a lot of uncertainty. You got to count the sets that you don't have you have zeros. There's differences between the killer whale and sperm whale depredations. But of course, fishermen try to quantify that. But, sometimes we're thinking maybe 10% increased cost. You weigh that against, are you in another fishery? There's quite a few things. It'd be great to, we know it, there's something there, but it depends also. There's just real quickly, we do take measures to avoid them by going in shallow, and we've had some successes with that as well. So the sperm whales don't like to get into shallow areas, not to fish, just to get away from them.
And I just brought up our analysis for the commercial gear. The title of this is called Change in CPUE by Vessel and Area in the Presence or Absence of Sperm Whales. So I'll send that to you. That's your